Hello and welcome for this presentation on Hadoop and HDInsight. My name is Anna, the Microsoft SAP voice, and I will voice this presentation for you today. HDInsight is Microsoft's implementation of the Hadoop framework. This presentation is largely based on a white paper from Syncfusion, a company that was founded in 2001 and specialized in developing components for the Microsoft Net platform. We'll first see the basics of Hadoop and next the installation of HDInsight in a single Windows system. Hadoop was initially jointly created by Doug Cutting and Mike Caffarella, and the story has it that Hadoop is the name of the elephant toy of Doug Cutting's son. Hadoop is basically an Apache server geared at processing large amounts of data. It consists of four pieces: the Hadoop Commons, HDFS, the Hadoop Distributed File System, the Resource Manager, and the most notorious map reducer. Apache Hadoop is an open-source software framework and a registered trademark by the Apache Software Foundation. Hadoop Commons is a package of Java libraries and scripts that operate the server. In the Hadoop distributed file system, data are scattered on many machines with a high degree of replication. It is a scalable system where the number of participants can vary from one to any number. HDFS is remarkable in that it was designed to work on low-cost, low-profile machines, and because any of these commodity machine can fail anytime, HDFS was devised to be very fault-tolerant. We see in this representation the same blocks of data. Blocks A and B exist on three machines, also called nodes. The metadata store at the top of the hierarchy is the Hadoop distributed file system itself. As we'll see later, these nodes are not only repositories for HDFS but also work nodes. It must be noted here how different HDFS is from traditional databases. Traditional databases generally reside on one or a small number of central computers with limited replication. HDFS data are highly distributed and duplicated. Databases, either hierarchical or relational, are highly structured. HDFS was designed to manage unstructured data. Consequently, the extraction and analysis of data also greatly differs from the processing of traditional databases. MapReduce is a programming model for processing large amount of data as imposed by the HDFS constraints. The data processing must be able to distribute units of work to multiple machines in parallel, collect and aggregate the outputs of all work units. Additionally, that processing must be fault-tolerant to support the failure of any machine during the process. It can be seen as a sort of grid computing. MapReduce executes in three steps. The map step divides the work in small units that can be handled individually by participants. The shuffle step consolidates the outputs from the mapping between nodes, and the reduce step again distributes small units of work to the participants in order to build the final result. Let's try to clarify this mechanism on a simple example. The goal here is to count how many times each word appears in these two lines from the children's song Twinkle Twinkle Little Star. The map processing sends each line to a different machine, creating an input key-value pair with the number of the line and the contents of the line. So node 1 receives key 1 and value Twinkle Twinkle Little Star. Node 2 receives in parallel key 2 and value How I Wondered What You Are. Each node analyzes the short fragment it has been sent. The output of each node is a set of key-value pairs. In our example, node 1 produces an output of 4 key-value pairs. Because the word twinkle has been found twice, 2 pairs are generated for this word. Note each word becomes a key in the output of the node, and the value is 1, the number that can be interpreted as one occurrence. In parallel, node 2 produces 6 key-value pairs. The shuffle stage consolidates the outputs of the mapping between multiple participants. The goal of that step is to ensure all key-value pairs for a given key go through one unique reducer. In our example, Node 1 and Node 2 have no key in common, so there is nothing to consolidate. If Node 2 had also found the word twinkle, it would have produced a key value for this word. In order to make sure all key-value pairs about twinkle go to one reducer, the shuffle would transfer the pair from Node 2 to Node 1. In our example, the shuffle results in key-value pairs where each word is a key and the value a list of ones. So the key twinkle is associated to a list of 2 ones. The reduce step also distributes units of work to nodes. The input to the reduce step are the key-value pairs the shuffle generated. Although unlikely, Node 1 might receive the key-value pairs from the second line and Node 2 process the output of the shuffle for line 1. The specific action in the reduce step would be adding the ones in a list. In our example, every word finally gives a key-value pair with a value of 1, but twinkle that would have a value of 2. This view from the Yahoo website for developers illustrates the Hadoop end-to-end processing, including all the MapReduce steps. Hadoop gained attention from being used by a number of popular companies well known to collect and analyze huge amounts of data. Furthermore, half of the companies in the Fortune 500 would have Hadoop already. Not surprisingly, the major IT vendors and solution providers have entered the Hadoop segment. On October 24, 2013, Microsoft launched the preview of HDInsight, an implementation of Hadoop in Windows. It can be downloaded at no charge from this page. It all starts with the execution of the web platform installer. Follow step by step as suggested. Before you try to use Hadoop, make sure these services have been installed and are running. The services can start automatically or be set up to start manually to avoid the overhead from running the services when Hadoop is not used. The installation creates a number of shortcuts on the desktop, and we are going to see their purpose right away. The MapReducer shortcut builds in the Internet browser page such as the one shown here. Note the URL. This page was actually generated by the Hadoop server. Its purpose is watching the active or inactive jobs in your Hadoop server. This name node shortcut retrieves information about the nodes this Hadoop server manages. The page contains a number of links. In particular, the Browse File System link allows to explore the Hadoop file system. Here's an example of the first-level directory contents in this implementation. The first name in the list is for the Hadoop file system. The last shortcut opens the DOS-like command line utility. It is very useful to load data to the Hadoop file system or get information from the server using commands rather than browse the web pages. Congratulations on installing your test Hadoop. So far you can't do much with your server, but a number of examples are available on the web. One place to visit is the Syncfusion page at the indicated URL. Thank you for watching. We hope you found this presentation useful. If you'd like to learn more about Hadoop, please visit the web pages that are listed in the references next. They are only a few among a growing number.